So in the lab, there was a lot going on. We were practicing not only doing PowerShell remoting, but also remotely executing functions from the local machine, the using colon syntax, but also larger issues too. Coming up later this week, we're going to talk about the problem of local admin accounts and managing their passwords. The recommendation is going to be don't use Microsoft Laps. Instead, we're going to look at a PowerShell solution that is actually better. Now, that local account had to be placed into the administrators group in order to remote into the machine with that local account. By default, when you remote into another computer, you have to be a member of the administrators group to do so. But now, in section number 2, we're going to talk about PowerShell JEA, just enough admin, and we're going to see that being a member of the administrators group isn't always required. PowerShell JEA is a remoting sandbox. When you remote into another machine using the JEA feature, all commands are blocked by default. The only commands you can run are those that are explicitly authorized. You can even control the parameters and the arguments to these allowed commands. So for example, you might allow a command to create user accounts in Active Directory, but only if that account is being created in a specific organizational unit, not any other OU in Active Directory, because we can filter or regulate the command line arguments passed into the parameters of these commands. But when commands are run inside the sandbox, the commands are magically elevated as though the user were a member of the administrators group, even though he or she is not. So it's kind of a paradox. By default, to remote into another machine, you have to be a member of the administrators group. But for the sake of security, we want to empty the administrators group as much as possible. But for IT people to get their jobs done, they often require administrator privileges. So with a JEA endpoint, as it's called, somebody remotes into the machine, they're using this JEA feature, they can remote in even though they're not a member of the administrators group. When they execute commands, the commands are magically elevated as though they were members of the administrators group even though they're not. And because we're trying to make this into a sandbox, that's why all commands are blocked by default. That person can only run the commands that we explicitly authorize, including the parameters and arguments that we explicitly authorize. So how can we have our cake and eat it too? How can we have something like a sandbox while at the same time allow magical elevation of privileges? If you have Unix or Linux experience, if this sounds kind of like a mashup between setuid root, restricted bash, and SSH, that's kind of what it is. But it's the PowerShell and Windows Remote Management Service version of all this. Something else too. All the commands that are run inside this JEA sandbox are logged. Now these are not logged to the event logs. These are written to separate textual logs called transcription logs. The commands, the command line arguments, and even the output of the commands, all of this is written to textual log files. So while we hope that the sandbox holds, we hope that no one could break into a machine using this JEA sandbox, well, nonetheless, we need to log everything that occurs so we can give that to the threat hunters, incident responders, and forensics people. Ideally, the log data will be fed over the network in real time to some kind of SIM, some security information event management system that can examine the commands in real time, alerting us when nefarious things are going on. But that's a whole separate course at SANS. Be aware that to use PowerShell remoting and a JEA sandbox like this requires Windows PowerShell 5.0 or later. Now, why emphasize that? Because PowerShell Core does not support JEA sandboxes like this. So it's one of the big limitations of PowerShell Core. When you remote into a machine and you want to use a JEA sandbox, it's got to be Windows PowerShell, not PowerShell Core. This module is really one big lab where we do all the steps together. And that's because we're going to look at these configuration files, and it's best, frankly, if you see it live On your machine, please run all the commands that are shown on the slide. In your manual, this is on page 45. Please run these commands. The way that you install this JEA sandbox is by running a configuration script. This is not a script from Microsoft, it's a script that I wrote, but it's a very simple script. You'll be able to modify the script yourself, no problem. Now when you run that script, it's called new JEA endpoint, you'll see some scary looking warning text, but don't worry, that's normal and expected. We're restarting the WinRM service, that's the service for PowerShell remoting, and whenever we restart that service, you see lots of scary warning text. Personally, I think this is overkill from Microsoft, it's unnecessarily frightening, but is normal and expected. Then you're opening up that script so you can take a look at it. We're going to refer to that script in just a few slides. And the main thing that that script does, it creates a PowerShell module folder and copies some files into that folder. So in the slide, you're navigating down to where PowerShell module folders are stored, and the name of the module is JEA test. It doesn't have to be named JEA. In fact, the module doesn't even have to have the letters JEA in the name of the module at all. Yesterday we talked about importing modules, and in this case, it's convenient to have all of the files related to this JEA sandbox in a module folder. That way we know where to find it, we have protected NTFS permissions, and we can more easily update or overwrite that module later on. So just keep in mind that in your environment, this isn't managed through group policy, or at least not directly. The way that this is managed is that you'll run a script similar to this one, it'll create the PowerShell module folder, copy some files into it, and then we'll run a special command that restarts the WinRM service. So the script itself is not that long or complicated, but it will have to be run on every machine where you want this JEA sandbox. And these configuration files that we're talking about over the next several slides, you could store these configuration files in a shared folder on the LAN, so that when you run the configuration script, you're downloading the configuration files from a shared folder. And any wild guesses how you might run this configuration script on 5,000 machines? Yes, it's PowerShell remoting, because we assume that you are a member of the administrators group. So you could remote into another remote machine, execute this script to create the JEA sandbox for the sake of others. And when you remotely execute this script, you could have the configuration files downloaded from a shared folder, or can you use PowerShell remoting to upload and download files? And of course, yes, you can. So the way that you would install this perhaps across 5,000 machines is that you would run, as someone who's already a member of the administrators group, you would run a script that would upload this script and the configuration files to the remote machine, remotely execute the script, and that would create the JEA sandbox. Now, later on, if you want to update that sandbox in its configuration settings, what you're really doing is uploading new files. So you upload new configuration files to the target box, you run a command to restart the WinRM service in a special way, and then now the sandbox environment is updated for your users. The configuration settings for this remoting sandbox, this JEA sandbox, they're not stored in the registry. They're stored in text files. These files have file name extensions of PSRC and .PSSC. So again, when you're installing this on thousands of boxes, these configuration files can be stored in a shared folder, uploaded by you through PowerShell remoting or SMB, and you could also do this up in the cloud. For example, Microsoft has support for this in the Azure cloud. In fact, there are even pre-configured sets of files in the PowerShell gallery. So you might not be an expert in, let's say, SharePoint server, but other people are, and they might create a set of configuration files for a JEA sandbox specifically for SharePoint servers, and they give them away for free in the PowerShell gallery. Now, you'll still have to download and examine those files to make sure that there's nothing, mysterious or bad going on, but at least you don't have to create the files totally from scratch. A nice way to organize all these files is to place them into a PowerShell module folder. Technically, this isn't required, but it's a nice way to organize all the files. And the name of the module that we just created is JEA test. It can be named anything you wish, though. So what are these configuration files? Well, the first one, the PSRC text file, this lists the commands that are allowed. Because with the JEA sandbox, when you remote in, by default, all commands are blocked. So that means we have to have a list of the commands that are allowed. And that's what the PSRC file is. You've already run the setup script to create the sandbox on your machine. So let's take a look at the list of allowed commands for this sandbox. On your computer, please run the command as shown at the bottom of the slide. Now, that command assumes that you have navigated down to the JEA test folder. So these paths are relative to the JEA test folder. Unless otherwise specified, please stay in the JEA test folder for the next several slides. Now, if you're not in that JEA test folder, that command, that's back on page 45. That was the slide that we saw, page 45. So you should be in the Program Files, Windows PowerShell, Modules, JEA test subdirectory. And then now you can execute this command at the bottom of the slide to open up that file in a new tab. Inside the file, you'll find, more or less, a big hash table. So remember that we have the equal sign that puts the key on the left and the value on the right. If you scroll down a little bit past the blank lines and the comments, you'll find a key named Visible Commandlets. Visible Commandlets is a list of all the commandlets that you can execute. You could put the names of all the allowed commands on one long line. That's perfectly fine. Or you can format it as shown in the slide, where you have a separate command on each line. That might make it a little bit easier to read and edit. You can list commands explicitly by name, like get process or get service, or you could use wildcards, like show-star or test-star. That will allow any command that matches that pattern. If you'd like to limit the commands to a particular module, like the AppLocker module, then the syntax is the name of the module, / and then the name of the command with or without a wildcard. So as you can see in the slide, we're allowing all the get commands, but from the AppLocker module. Now these are all commands that are built into PowerShell. What about your own custom functions? As you can see at the bottom of the slide, you have another key in this hash table called Visible Functions, followed by the names of the functions that you want to allow. And where are these functions implemented? Where's the code for these functions? It would be in this file. This file that we're editing right now, it has not only the names of the commands and functions that you can run, but also the code for those functions. So in this file near the top, you would copy and paste in the functions that you want to allow to run. So remember in the prior module, we did PowerShell remoting where you could inject a copy of your function into a remote session. Well, in a sense, that's what's going on inside of this file. In this file, you could have, let's say, hundreds of your favorite functions, including all the code, not just the names of the functions. And when somebody remotes into the machine, all of these functions will be copied into that remoting session. So visible functions here is simply the names of the functions, but higher up inside the script, maybe near the top, that's actually where the code of the functions would exist. Let's imagine that you want to allow the getProcess commandlet, but you want to restrict the parameters and arguments that can be passed into that commandlet. So, for example, I go back to my command shell. I could allow just getProcess by itself, and that outputs all of my processes. But on the other hand, getProcess has a parameter named name, and that could take an argument, like, for example, the name of a particular process, like the winlogon process. So getProcess is the commandlet, -name, that's the parameter, and the name of that parameter happens to be name, and winlogon, that's the argument to that parameter. So how can I restrict the parameters and the arguments? Notice that visible commandlets is a key in a hash table, but the data for that key is itself another hash table. So here we have @ opening squarely brace, and at the very bottom of the slide, there's the closing squarely brace. So let's imagine that you want to allow get process, that's the name of the command, and you also want to restrict the parameters. So in this little hash table, notice that parameters is a key, and the data assigned to that key is again another hash table. You can embed a small hash table inside of a larger hash table, and of course this entire file is effectively one big hash table. So we talked about hash tables very briefly yesterday as an introduction, but now we see that hash tables are a really useful way for structuring nested or embedded complex data. In fact, we're going to see hash tables several times this week. On day 6, for example, we're going to create like a DevOps script, and we're going to store lots of settings inside of hash tables like this, like usernames and passwords and other settings. So what's the formatting here? Again, the name of the command we want to allow is get process. The parameters key contains a hash table with a list of all the parameters that are allowed. Now in this case, what's the name of the parameter that we want to allow? It just happens to be that the name is name. So the name of the parameter is name, -name. And what are the arguments that we want to allow into this parameter? Validate set is a list of all the legal or allowed arguments. So this means you can run get process, but the only parameter you can use is the -name parameter, and the only arguments you can pass in are svc host and winlogon. If you try to pass in any other argument or use any other parameter, well then the command will be blocked. What if the arguments you need to pass in would be a very long list of arguments? Maybe hundreds. It might be more efficient to, instead of having an explicit list of arguments, to instead have a regular expression pattern and only allow arguments that match the regex pattern. And that's what you can see on the next slide. This is very similar, except that notice that instead of validate set, now it says validate pattern. And the only arguments that you can pass in are the arguments that match that regular expression pattern. With regular expressions, you can define very complex or precise patterns to tightly regulate the arguments that are passed in. Because of time constraints, we can't do a whole module on regular expressions, but you can find tutorials on the internet for free. Learning regular expressions is a great investment, not just for PowerShell, but for other programming languages and tools as well. So in this case, the name of the command that's going to be allowed is getService. That also has a parameter named name. And in this case, the argument passed in has to match that regex pattern at the bottom. What about traditional tools like ipconfig, sc, whoami, and all the other text-oriented binaries? Well, those are supported too. These are called external commands. So in that PSRC file, you can scroll down a little bit further. You don't have to type this in. We have visible external commands. When you use this feature, remember that each of these binaries will be executed with elevated privileges. So you want to give the full explicit path to the binary, not just the name of the binary, and carefully choose which binaries you want to allow. For example, ipconfig is probably safe, but what about sc? sc is a command line tool for managing services and device drivers. So this might be too dangerous to allow inside the sandbox. Because if I can run the sc tool with elevated privileges, I can manage services and device drivers on the machine. That might allow me to break out of the sandbox or execute malicious commands that impact others on the computer. But what if we're stuck? What if we just have to allow the sc tool to be executed? What we need is something like a wrapper for the sc binary, some kind of wrapper that would tightly control the arguments that are passed into it. Ah, yes, that's right. If I go back a few slides, remember we have a key called visible functions. followed by the names of the functions that are allowed. And where are the code for these functions? The code is right here in this file. So imagine that you write a function that executes the SC tool and tightly controls the arguments that are passed into the SC tool. So in this case, you couldn't run the SC tool directly, but you could run a function that runs the SC binary. Now the function then would tightly control the arguments that are passed in. In your own function, you could validate those arguments or simply hard code those arguments when the SC tool is run. Now this also implies that if a command is allowed and that command launches another process, well, that other process is also allowed. And that other process is also going to run with elevated privileges. So if I remote into the machine, let's say with a local account named, Jason, I'm allowed to run a function. That function executes with elevated privileges. That function runs a bunch of other commands and a bunch of other binary programs. Well, all of those are indirectly allowed as well. And all those other programs and commands, those also run with elevated privileges. Okay, now how about that issue? Because this is important for making this a sandbox that someone can't break out of. And think of how we're playing a dangerous game here, right? We want our cake and eat it too. It's the paradox of this sandbox. We're blocking all commands by default. We allow commands only if they're explicitly listed. But if an explicitly allowed command launches another process or executes some other command, well, those other processes and commands are indirectly allowed as well. And that makes our sandbox more useful and fun, but at the same time makes it easier for our adversaries to break out of that sandbox. And again, it's not our users really that we're worried about. It's instead our users' credentials are being stolen by hackers. And it's hackers with the stolen credentials of a user who is permitted to connect to the sandbox. And now the hacker knows about these JEA sandboxes. They know that the commands are magically elevated. And it's the hacker now who's kind of probing through the corners and figuring out how to break out of that sandbox or execute malicious commands, even though we're trying to block it. So just be aware, if you allow a command, like a function, that executes other commands or launches other processes, well, those commands and processes, those run elevated as well. So dangerous, but on the other hand, what else are we going to do? As you might imagine, these files are getting rather long and complex. They have weird complex syntax. We can have hash tables nested inside of hash tables. And let's imagine that you need to allow dozens or hundreds of commands. And now we're trying to control all the parameters and arguments to these commands as well. So yes, you can create and edit these files in a text editor, but I think that's going to be highly prone to error. Wouldn't it be nice if we had a free graphical tool that could be used to create and edit these files and have the graphical tool check our syntax for errors for us? And in fact, we do. A free graphical tool from Microsoft is the JEA helper tool. In fact, it's already in your SANS folder. In the bottom left-hand corner of your slide, you can see the path to the JEA helper tool. Now there's a recommended way of launching this. Inside of PowerShell ISE, please pull down the File menu and select New PowerShell tab. So File menu, New PowerShell tab. And now in that new tab, now please give the full path to launch the JEA helper tool on your machine. Here's the full path. It's in your slide, but it's also here on your screen. So in a new PowerShell tab, please run // tools JEA helper, and then the name of this graphical tool is JEA helper tool. Hey, look at that, .ps1. So can you implement a graphical application with an uncompiled PowerShell script? Yes, you can. because PowerShell is just a wrapper for the .NET framework, and the .NET framework allows you to design and run graphical apps, that means you can have graphical apps written entirely in PowerShell scripts, uncompiled PowerShell scripts. Now, the reason that we opened up a new tab here is that when you launch the tool, it shows a bunch of status information inside the tab, and it can hold that tab. I mean, the blinking prompt, it doesn't return to you until after you exit out of the graphical app. So that's why it's nice to open up a separate tab here. But this is a graphical app written entirely in PowerShell. Because it's not compiled, it's not like C# or C++, it doesn't run as fast as a compiled graphical program, but it is a graphical app. All right, so in the IC editor then, please pull down the File menu, select New PowerShell tab, and then in the tab, please run this command as shown at the top right here. It's also in the slide. Using this graphical tool, we can create and edit all of the configuration files for these JEA sandboxes. Right now, we want to go to the second tab, the one that says Role Capabilities Design. Sometimes when you launch this graphical tool, it launches in the background. So if you don't see it, then use your mouse and hover it over the PowerShell icon down at the bottom. You might see it there, or you can do like an Alt-Tab to bring it to the foreground. On your machines, if you just want to watch me do it, feel free to watch, or go ahead and launch the graphical tool on your machine too to play around with. In the JEA Helper tool then, if you're following along, please go to the second tab, the Role Capabilities Design tab, and now you could start from an existing file, or you could make a whole new file. To make a new one, in the middle, there's a pull-down menu. It says you can pick a commandlet. When I click on that menu, it may take a few seconds for it to respond. Again, it's not as fast as a compiled graphical app. But when you click on that menu, scroll down, pick a command, doesn't matter which one you pick. And then to the right of that, after a couple seconds, you'll have another pull-down menu where you can check the boxes for the names of the parameters and switches that you want to allow. Now, once you've selected the command and optionally check the boxes for some parameters, then on the right-hand side, click Add to Grid. Now, the grid is the little table that you see in the middle of this graphical app. Down below, you can see that it's also generating a syntactically valid PSRC file. This is the text file that contains the list of all the allowed commands. That's the file with the weird, complex syntax. The syntax that's really easy to mess up. But the nice thing is, we can modify the grid, the little spreadsheet or table here in the middle of the app, and it'll update the syntax down at the bottom for us. So it's showing us that syntax, but we don't have to edit or modify that syntax at the bottom. It's a lot easier to use that grid. Notice in the grid that it gives the name of the command, the name of the allowed parameter, and if necessary, the arguments, or way off to the right-hand side, validate pattern, the regular expression pattern. You can click with your mouse and directly edit these fields. So in this case, it's a lot more fun to edit these files with all the complex hash tables using this grid or table in the middle. Going back up to the top of the tool, it says you can add a full or partial module. There's a little pull-down menu. So yesterday we ran commands to list all the modules on the machine. In the background, that's what this is doing. When you click on that menu, it might take a couple seconds for it to appear, but then you can pull down the menu and select a module, like for example, the App Locker module. If you click Add to Grid, the module will be added to the grid down below, and notice that it says App Locker star. That indicates that all of the commands from that module are permitted. Or, if I pull down the list of modules and I choose a different module, I could select Add Get Star Only. Now, the get commands are commands that read information, but typically don't modify anything, so these would be safer to run. Picture an auditor or a threat hunter who needs to gather lots of information but not make any changes. So we could allow them to run any get commands or show commands, but not the commands that modify things. If you need to import a module, you can click on the Import Module button. And finally, as you can see, there are checkboxes where you can select the rows in the grid, this little table here, and then do things like add row or remove roles. Once you're all done, you can save your changes to an existing file or to a new file. The other files that we need for these JEA sandboxes, they can also be created and edited using this graphical tool. In the slides, we're looking at the raw files themselves so that we understand what's going on, but you don't have to create and edit these files in Notepad. That just takes way too long and is far too prone to error because the syntax is so weird and complex. So as we go through looking at these configuration files for the JEA endpoints, please keep in mind that you don't have to use Notepad, you can use this graphical tool. If you use Microsoft Azure, then there's also nice, friendly web interfaces for your browser for creating these role capabilities, selecting the tools, and so on. So up in Azure, they have even better graphical tools that pretty much hides all the weird syntax in the background. Let's imagine then that we've created the PSRC file. Now that's the file that has a list of all the allowed commands and command line arguments. Maybe we created that from scratch, or used the JEA helper tool. Maybe we downloaded it from the PS gallery, or maybe we're putting our virtual machines up in Azure and Microsoft has a whole library of these configuration files for us to use. But one way or the other, we now have the file with the list of allowed commands. We now need to create a second configuration file, a different one. Now, before we create that file, a little bit of terminology. When you remote into another machine, you get a PowerShell session in the memory of that remote machine. One computer could have many sessions running in parallel simultaneously. So, for example, a domain admin might remote in using a normal remoting session, whereas another user, let's say Bob or Alice, remotes in using a JEA sandbox. In both cases, the people who are remoting in are talking to the WinRM service, the Windows Remote Management Service. And it's the job of that service to juggle all these different sessions and all the different rules that apply to the sessions. A set of remoting rules that the WinRM service enforces is called an endpoint. I really wish Microsoft did not use the word endpoint here, because that implies that an endpoint is either a machine or a listening port. But it's not. An endpoint is a set of rules that the WinRM service applies to a remoting session. And depending on the endpoint that applies to your session, that'll determine who can connect and what commands they can run. So for example, there's the default endpoint, the default set of rules. And those rules specify that to remote into a machine, you have to be a member of the administrators group. And what commands are blocked? None. By default, when you remote in, you can run any commands that you wish. Nothing is blocked. Now, by contrast, we're going to create a new endpoint, a new set of rules. And this endpoint, this set of rules will specify that you will have to be a member of one of, let's say, 3 different groups, but not the administrators group. You have to be a member of at least one of these 3 different groups. And depending on what groups you're a member of, that'll determine what commands you can run. Because in this other endpoint, in this other set of rules that we're going to impose, all commands are blocked by default. Now, to make this all a little bit more concrete, how can you see what endpoints exist on your machine already? Well, you can run the command get PS session configuration. So I'm going to run that on my machine. I switch back to my first PowerShell tab and I run get PS session configuration. Thank heavens for tab completion. It's a very long named command. You can run this on your own box if you wish, or you can just look on my screen. So I've run get PS session configuration. Notice that I have this thing, permission. That's a list of the groups that are permitted to remote in and to use this endpoint. So I've got an endpoint called Microsoft.PowerShell. And I've got another one, this is another endpoint, another set of rules called Microsoft PowerShell Workflow. And I've got another one for 32-bit PowerShell as opposed to 64-bit. And if I scroll down just a little bit further, this is really the main thing I wanted to show. Here is a remoting endpoint specifically for Server Manager. Now, I really wanted to show this because Server Manager is not a command shell. Server Manager is a graphical app. So as we talked about yesterday, PowerShell really is a set of DLLs. These DLLs can use PowerShell remoting, and these DLLs can be loaded into graphical apps. So on my machine, I click on the Start menu, I launch Server Manager. Now, in Server Manager on the left-hand side, imagine I go to All Servers, and I add a list of all the machines that I'm responsible for, including Server Core. So sitting at my workstation, I could use Server Manager to connect to Server Core VMs or Server Core physical boxes over the network. And now I can do things like pull down the Manage menu and add and remove roles and features from remote machines. But how is Server Manager getting its job done? What protocol is being used? Yes, it's PowerShell remoting. Because built into Server Manager, built into this PowerShell-enabled graphical app, Server Manager has the PowerShell DLLs loaded into it. It can use PowerShell remoting too. So, as we're talking about PowerShell remoting today, we're doing lots of work inside of command shells and using scripts. But remember that PowerShell remoting is also for graphical apps. And as we're creating a JEA sandbox, let's say for a non-technical user, let's say Alice and Bob are non-technical users, they can barely double-click. But we've hired some developers to create a graphical app that Alice and Bob can run by clicking on things, lots of built-in help and menus and all that good stuff. But in the background, that graphical app is using PowerShell remoting to connect to a JEA sandbox where all commands are blocked by default, and the only commands that are allowed are the ones that we explicitly allow. And those are the commands that the graphical app is designed to use. So as Alice and Bob are clicking on icons and pulling down menus and whatnot in their graphical apps, in the background, that graphical app is using PowerShell remoting to remotely execute commands and functions, but only the commands and functions that we allow. So imagine creating a JEA sandbox specifically for a graphical app. You then install that graphical app on the desktops of various people, let's say auditors. We allow those auditors to connect based on their group membership, probably a group named auditors. So please keep in mind then that PowerShell remoting is not just for scripts and command shells, it's also for graphical apps. And in fact, you have a remoting endpoint already from Microsoft specifically for Server Manager. So what we're going to do, we're going to define our own new additional endpoint, but with different rules. So one machine can have multiple endpoints, multiple sets of rules, maybe one endpoint for traditional PowerShell remoting in a command shell. You've got another endpoint specifically for Server Manager, a graphical app, but we can create more endpoints for more graphical tools or for other scripts and other interactive command shells. So PowerShell remoting, in some ways, is like RPC. Graphical tools can use RPC in the background, but graphical tools can also use PowerShell remoting. And can we do PowerShell remoting over the internet using TLS encryption? Yes, we can. So now we see that PowerShell perhaps is a lot more broad. It's a lot bigger than just scripts and command shells. This is the future of Windows remote administration, whether it's scripts, command shells, or graphical tools. Whether your machines are on premises inside the air gap, or in the DMZ, or hosted up in Amazon Web Services or Azure somewhere, no matter where those machines are all around the world, as long as I can establish a TLS encrypted channel to that computer, I can now use scripts, command shells, and graphical apps to remotely manage these machines. Ah, but it's the double-edged sword again, right? The double-edged sword. If our adversaries are able to steal our credentials, our adversaries can do the same thing. Now, how do we define our own custom endpoint? Well, we need to create, or rather, we need to edit another text file. This is a file that has a file name extension of .pssc. This file already exists on your box, so if you'd like to take a look at that file inside your editor, please run the command as shown at the bottom of the slide. This assumes that inside your shell, you're still inside the JEA test module folder. You're still in the JEA test folder, so you might have to switch back over to that other tab inside the ISE editor. And then you can run ISE.\sessionconfig pssc. So several minutes ago, we ran a command to create an endpoint on our box, and this was one of the files that was copied to the module folder. If you don't want to open up that file, you can just sit back and relax, because we're going to look at, on my screen, the essential lines from that file. All right, so if you want to follow along, if you want to take a look at that file, please open it up. Can this file be created and edited using the JEA helper tool, that graphical tool? Yes, you can. So if you don't want to open this up in your text editor, you could use the JEA helper tool instead. Now inside of this file, if you scroll down a little bit, you can find the session type line. Session type must be set to restricted remote server. In fact, this is what makes it a JEA endpoint. This is what blocks all commands by default. The transcript directory is the path to the folder where you will write your textual transcription logs. The logging of all the commands in your command line arguments, that doesn't go, at least in this case, it doesn't go into the event logs, it goes into textual log files. Later on this week, we're going to talk about all the different flavors of logging that PowerShell supports, and this is one of them. If you want to write your logs to a shared folder that is supported, just be aware that if you have networking problems, the log data won't get written, and if you have a slow network, then there could be a performance penalty for this. Run as virtual account is where the magical elevation occurs. If you set run as virtual account to false, that means you will remote in as yourself, let's say as Alice or Bob, and you'll execute commands as yourself. Meaning, if you're not a member of the administrators group, there's no magical elevation. So run as virtual account equals false, that means no magical elevation of your privileges. But if you set run as virtual account to true, that means you'll log on as yourself, but you don't run commands as yourself. The commands are actually executed as this virtual account that's just fabricated out of thin air. Now, it's not a real user account in Windows or an Active Directory, but it does have a SID number. It exists only in memory, only temporarily while you are running commands inside the session. And then once you log off, it just poof, disappears. But that virtual account that's just fabricated out of thin air in memory, that account is treated as though it's a member of the administrators group. And because you're executing commands as that virtual account, that means your commands also run as a member of the administrators group. All right, so if you don't like this magical elevation of privileges stuff, you could still have a JEA endpoint. You'll then set run as virtual account to false. And that means people will run commands as themselves. If they are members of the administrators group, then great, they run elevated. But if they're not members of the administrators group, they can still remote in, but they run commands as themselves with like normal standard user privileges. Now let's imagine that you do set run as virtual account to true. In other words, you're remote in, and now your commands are magically elevated. Things are now a little bit scary. What if we accidentally allow too many dangerous commands to run? What if we allow somehow the attacker to break out of the sandbox? Well, we want to try to block this. So language mode should be set to no language. At the end of the course, on day 6, we're going to talk about PowerShell security, and that's where we're going to talk a lot more about language modes. But the short of it is this. If you set the language mode to no language, then what can you do in PowerShell? Very little. You can run commands by name and pass in arguments, and that's about it. In no language mode, you can't use any flow control keywords like while, for each, or if. And you can't do dangerous, scary things like compile C# code in memory to a DLL in memory. And you can't do scary things like call functions from the Windows API, that's the programming interface to the kernel of the operating system. We're going to talk more about this in the Day 6 manual when we talk about PowerShell security. But the short of it is this. For a JEA endpoint, we want this to be like a sandbox. We want to strip away everything we can. So by default, all commands are blocked except for the commands that we explicitly allow. But what about all the other bells and whistles of PowerShell? Like, for example, using flow control keywords. Well, when you set language mode to no language, all those bells and whistles, those are turned off as well. And that's good because we want to make this as much as an airtight sandbox as possible. Now, if you've opened up that file in a text editor, if you scroll down a little bit further, you'll now see these lines. So again, we're still inside that PSSC text file, that second textual configuration file. The question is, who is permitted to remote into the machine and use this endpoint? In your slide, you can see a list of groups in blue. Service admins is a local group. Help desk and contractors, those are groups from the testing domain, probably global groups. The idea is that to remote in and use this sandbox, this JEA endpoint, you have to be a member of at least one of these groups. You don't have to be a member of all 3, but you do have to be a member of at least one. So when you create this JEA endpoint, this remoting sandbox that people can connect to, it's not any old authenticated user in the forest. We get to control the groups that are permitted to use this endpoint. So you can have a list of groups that only has one group in the list, or you can have a list of 50 groups. And again, you have to be a member of at least one of the groups in order to remote in and use this sandbox. Now let's imagine that I'm a member of the contractors group. The organization has hired outside contractors to perform an audit. So we've created a new group in Active Directory named contractors. I remote in. Sure enough, I'm a member of the contractors group. But now the question is, what are the commands that I'm allowed to run? Well, that's where role capabilities comes in. Off to the right-hand side in red, it says auditors. That is not the name of a group. That's the name of a PSRC file. Unfortunately, you can't put the file name extension here. So auditors refers to a file named auditors.psrc. Now remember that in this module, we looked at a file, a text file, with a list of allowed commands. That's the PSRC file. So this auditors.psrc file is a list of allowed commands. Those are the commands I'm permitted to run if I'm a member of the contractors group. So having the contractors group here on the list does 2 things. First, I'm permitted to remote in and use this sandbox at all because I'm a member of one of these groups, in this case the contractors group. But then second, associated with the contractors group is a file named auditors.psrc, and that's the text file that has the list of the commands I can run. That's that first file that we looked at. Now, what if I happen to be a member of all 3 of these groups, service admins, help desk, and contractors? Well, in that case, all 3 of the associated PSRC files in red, all 3 of those files are simply merged together. And that creates one big list of all the allowed commands. The big idea here is to do role-based access control. For each major role in the organization, there'll be an associated group. And associated with each group is a list of the commands that that role needs to be able to execute to fulfill the role. In other words, to get their jobs done. So if I do happen to be a member of, let's say, all three of the groups that you see here on the slide, then all three of the associated PSRC files, serviceadmins.psrc, userassist.psrc, and auditors.psrc, all three of those text files will be merged together to create one big list of the commands I'm permitted to execute. So this is very flexible, but it's also somewhat complex. Because stepping back for a second and thinking about the big picture, an endpoint is a set of rules, these rules that we're talking about right now. But one machine could have multiple endpoints, like for Server Manager or for the auditors. And each endpoint has its own separate rules. And those rules include lists of allowed commands. So it's very flexible, but it also makes it complex. Now, the good news is when you are first getting started with JEA endpoints, you don't have to dive into the deep end to begin with. For example, you might create just one endpoint only allow one group, let's say the contractors group, to connect to it, and then just have one list of allowed commands. And that is a nice way to get started. We could start out relatively simple, and then only later add more endpoints or more groups and more lists of allowed commands, but we don't have to dive into the deep end to get started this way. Can we create and edit this file using the JEA helper graphical tool that we saw a couple slides ago? Yes, you can. So that's just a different tab inside that graphical tool. So now let's imagine that we've either created or copied from someone else these two files. We got the PSRC file with a list of the allowed commands, and now we just created the PSSC file, the file that defines the endpoint. We have to give these files to the WinRM service. We're telling the Windows Remote Management Service, okay, WinRM service, we need to create a new endpoint, and here's the PSSC file with all the information about it. This is done with the command as shown in the slide on page 68. Register PS session configuration is where you give the path to a PSSC file, the file that we just created a minute ago, and we give that file to the WinRM service. Sorry for all the acronyms. But we give that file to the service and we say, okay, Windows Remote Management Service, here's the necessary information for creating a new endpoint, a new JEA sandbox. And create that endpoint and give it a name of Sec505. So we saw a few minutes ago that we have multiple endpoints with names, and one of those is specifically for Server Manager. It had a long name. But you don't have to give it such a long name. In this case, I'm just giving it a short name, Sec505. This command has already been run for you by the setup script. So that first script that we ran in this module, that script created a module folder, copied a couple of configuration files into it, the PSRC file and now this PSSC file, and it executed this command. This is the command that showed all that scary warning text on your screen when the WinRM service restarted. Now the endpoint is all ready to go. Now we can connect to that endpoint as a regular user and then see the commands that we run get magically elevated. If we remote in as ourselves, that's not very fun, because we are members of the domain admins group and the administrators group and all the other powerful groups that we're worried about. Now, on the other hand, you have an account in Active Directory named Amy. Let's imagine that Amy is an auditor. Amy happens to be a member of the service admins group that was mentioned on the prior slide. But let's imagine that this is a contractor who's doing some audit work. We don't want to place these contractors into the administrators group, so that's why we created the JEA endpoint. Now on your computer, this is where it's hands-on, because we actually want to connect to this endpoint and see what it looks like. So on your machine, please run the two commands that you see here in the slide. In your manual, this is all on page 66. So on your machine, please run these two commands. We're going to do $creds equals get credential. The user in this case is Amy, and Amy has the same password as you. Now at the bottom of the slide, we're not going to use a graphical app. We're going to use enter PS session just like we did before. But notice, I'm passing in the credentials to use explicitly. I'm not going to use single sign-on and log on as myself with Kerberos. I'm going to authenticate explicitly, in this case as Amy. The computer in this case happens to be localhost, but let's just imagine that it's a remote machine. And we don't want to connect to the default endpoint, so we have to give the name of the endpoint to connect to. So we do -configuration name sec505. That's the name of this new endpoint that was created when we ran the setup script. And I'm going to run the same commands as you. So back in PowerShell, I do $creds equals get credential. The username is Amy. The password is the same as your password. And now when I do enter PS session, the computer I'm going to connect to is localhost. That's where the sandbox exists. That's where the endpoint was created. The credential is the $creds variable, because I want to authenticate as Amy. And the configuration name is sec505, because that's what we named this endpoint. Again, we could use a graphical tool with this command hard-coded into it, but we're going to do it in the command shell just to get more practice doing PowerShell remoting. Again, these are the two commands that are shown on page 70 in your book in the slide. So now, oh, I forgot. Earlier I messed with Amy's password, so on my machine at least, I need to go reset Amy's password. If anybody else got that authentication error, then let's see, where did I put Amy's account? There it is. So in this case, I forgot. So I'm resetting Amy's password back to what it should be. Now I go back to PowerShell again. I'll run that same command. Oh wait, I never ran the script myself. I apologize. So if I go to day 2 and then the JEA test folder, there we go. So I needed to run that same script as you. So this was that script several slides back. This is a script that creates the module folder, copies the files in, and we get all the scary warning text about restarting the service. But once this script runs, then the JEA endpoint will have been created on the machine. There we go. Now the sec505 endpoint exists. Now I can run that command and avoid the error message. So there we go. I just remoted into my machine as Amy. I didn't connect to the default endpoint where all commands are allowed. I connected to this JEA sandbox. So now I eagerly try a command like maybe dir, but that's not on the allowed list. This is what it looks like when a command is blocked. On the other hand, if I run get process is allowed, and the command works. I can see the output when I run get process. How can I get a list of all the allowed commands? One of the commands that's allowed is the get command command. So get command normally will list all the commands in PowerShell unless you're in the JEA sandbox. When you run get command inside of a sandbox, it only shows the commands that are available or visible inside the sandbox. So there are thousands of commands in PowerShell by default, but as you can see, when you run get command, we only have a small number here. Notice too that tab completion does not work. Tab completion is implemented by a module which is not loaded or imported for safety reasons. So if I type in, for example, get dash and I start hitting the tab key, nothing happens. So tab completion being broken, that is expected and normal, because tab completion, you're actually communicating with a PowerShell module that might be exploitable. Now, one of the commands that is allowed is whoami.exe. Who am I will show you the identity under which this session is running. This is the identity under which the commands are being executed. But remember, we authenticated as Amy from the testing domain. The name of our domain is testing. But here, it shows that the name of the domain is WinRM virtual users. There is no such domain. That does not exist anywhere. This is just a domain that's just fabricated out of thin air by the WinRM service. And the same thing for the username portion. That user does not exist. That's not a local account in the registry of the machine, and that's not an account in Active Directory either. That's just an identity fabricated on the fly out of thin air by the WinRM service. But notice that Amy's username is incorporated into this fabricated account, fabricated out of thin air. And Amy's domain name is also incorporated into the username that you see. This is useful because, remember, with transcription logging, all these commands are being logged, and how could I associate the command with the person running the command? Well, in this case, you would look at the fabricated username, and you would extract the real username out of the end, and the real domain name out of the middle. But there's more. Who am I can also show you all the groups and all the privileges that this session is operating under. So if you run this command on your machine, who am I /all/FO for format, space list. So who am I /all/FO, then list. Technically, this shows you the security access token associated with this session. But what we care about is that it lists the groups that this virtual user is considered to be a member of, and it lists the privileges that this virtual user account has as well. I've scrolled back up to the top after running the command. This account has a SID number, a security ID number. If I scroll down about halfway, notice this virtual account is considered to be a member of the administrators group. That's why when you execute commands inside this sandbox, the commands run with the privileges of the administrators group. It's considered to be a member of that group. Now again, this user account doesn't actually physically exist, so if you examine the current membership of the administrators group, you will not find this virtual account in the administrators group. So it's treated as though it's a member of the group, but it's not actually a member of the group. And if I scroll down a little bit further, yikes, look at this. Because this endpoint was created on a domain controller, this virtual account is also considered to be a member of the domain admins group. So imagine we've got a user named Amy, that's a contractor, who's doing an audit. We create an endpoint on a domain controller, not just a regular file server. And when this contractor remotes in, commands are magically elevated to full domain admin. So we have to make sure that this sandbox is airtight. In fact, when you're first getting started with JEA sandboxes like this, you might have a policy that says you cannot create these sandboxes on domain controllers. So when you remote into a non-domain controller, you'll be a member of, or you'll appear to be a member of the administrators group on that non-controller. But if the sandbox is created on a domain controller, then you're also virtually added to the domain admins group. Very scary. On the other hand, maybe that's what we need. Because we have auditors, for example, who need to query Active Directory and run reports. So the auditor might call you up on the phone and say, hey, you got to put me in the domain admins group. And you say, what for? I mean, you're some outside contractor. We're not going to put you in the domain admins group. And the auditor says, well, I'm sorry, but I've been hired to perform an audit, including an Active Directory audit. You got to put me in the domain admins group or else I can't do my job. Now, in this case, we find out that the auditor only needs to read information, not modify anything. So in that case, after doing some testing, we create the endpoint on a domain controller, just one controller. We tightly restrict access to the port 5985 or 5986, so we only allow the workstation of the auditor to connect to that one controller on those ports. And we restrict the commands that the auditor is permitted to run. So the auditor can run the get commands, but not any commands for setting, removing, or any commands to create new things. So the auditor can read information, but not modify anything. So that's kind of the hope, right, of setting up these JEA sandboxes. We can allow people who, under other circumstances, we would just have to bite the bullet and grudgingly put them into, let's say, the administrators group or the domain admins group, even though that's, a huge risk and very scary. But the hope is that with these endpoints, we don't have to do that. We could tightly control the commands they can run, tightly control the ports and the IP addresses that they can connect from, and now we can hopefully delegate these powers, these privileges in a safer way. And keep in mind too that we are logging everything that auditor does. All right, and that is the taste then of using a JEA sandbox. This is the future of PowerShell remote administration. Is PowerShell remoting only for command shells and scripts? No, it's also for graphical applications too. I'm emphasizing this over and over again because later on this week we are going to look at a graphical application that can also use a JEA endpoint. But the developers in your organization, they can easily create these graphical apps as well, including web applications. So imagine that you expose to the contractors not a regular graphical app that they install on their own hard drives, but instead your developers create a web app that they access with their browsers. And by going through the web application, it's the web server that opens up these remoting connections to these sandboxes on other machines inside the LAN. And now we have a nice friendly web application for contractors and anyone else who needs these elevated privileges.